Hello everyone, welcome to Theory of Computation tutorial, and the topic is Non-deterministic finite automata, NFA or NDFA, presented by Vaibhavi VP. Definition of non-deterministic finite automata. The non-deterministic finite automata, in short NFA, is phi tuple or quintuple indicating phi components, that is m, which is equal to q summation delta q naught a, where m is the name of the machine. It can also be called by any name. Q is the non-empty finite set of states, and summation is the non-empty finite set of input alphabets, and delta, where q cross summation to 2 power q, that is q is a transition function which is mapping from q cross summation to 2 power q based on the current state and input symbols. The machine enters into one or more states, and q naught belongs to capital Q, which is the start state, and a is a subset of capital Q, which is a set of accepting or final states. Now let's come to the problems. The first question is, design an NFA for set of all strings that starts with 0. And the diagram is Q0 and Q1 are the two states. Q0 is the initial state and Q1 is the final state. For final states, we put two rounds, and for the first arrow indicates the initial state, and as per the question, the string should start with 0. So the Q0 is the initial state which start with 0, and the string can end with any number of zeros or 1. Now m equal to q, comma, summation delta q naught a, where capital Q is a non-empty finite set of states, that is, from this diagram, Q0 and Q1 are the non-empty finite set of states, and summation equal to 0 and 1, which are the non-empty finite set of input alphabets, and Q0, which is the initial state, and A is the final state, where Q1 is the final state in this diagram. Delta equal to, now we draw a transition table for transition function, state, and input symbols. Well, for state Q0, for that is the initial state, when the input symbol is 0, it moves to the Q1. As per the question, the string should start with 0. So the 1, for input symbol 1 there is null, and for final state Q1, when the input symbol is 0, it moves to Q1, and when the input symbol is 1, it moves to Q1. That is a self loop. The final state has any number of zeros or 1. Now come to the second question. Obtain an NFA for set of all strings that ends with 1, 1. There are 3 states for this question. Q2 is the final state, so we put 2 rounds for to indicate the final state, and the string should end with 1, 1. So the starting state could have any number of zeros or ones. So we take the self loop of any number of zeros and ones for the initial state Q0, and as per the question ends with 1, 1. We take the 2 states, that Q0 to Q1 1 and Q1 to Q2 1. M equal to Q summation delta Q0 a, Q, where capital Q is equal to Q0 Q1 Q2, which is the non-empty finite set of states. Summation is a non-empty finite set of input alphabets, that is 0 and 1 are the input symbols for this summation, and Q0 is the initial state, and here Q0 is the initial state in this diagram. A is the final state, where Q2 is the final state. transition function, we draw a transition table, that is state, input symbols, that is 0 and 1 for this question. Initial state q naught, when it has the input symbol 0, it moves to the q naught, and for input symbol 1, q naught and q1. For the state q1, when the input symbol is 0, it is null, and for input symbol 1, it moves to the q2. And the final state q2, when the input symbol is 0 and 1, it is null. Now let's move to the third question. Obtain an NFA for set of all strings that contains 0. And this is the diagram for this question. It has two states, q0 and q1. The initial state is q0 and the final state is q1. So we put two circles. The the string should contain 0. So there are two states which contain 0, and it can start with any number of zeros and ones, and it could end with any number of zeros and ones. So we take the self loops for both the states which contains the 0. M equal to q delta summation q naught a, where capital Q is equal to q naught q1, which are the non-empty finite set of states, and summation equal to 0 and 1, which are the non-empty finite set of input alphabets, and q naught, here in this diagram the initial state is q naught and a is the final state. In this diagram q1 is the final state, and the transition function, that is we draw the transitions table where it has state and input symbols. q0 is the initial state, and for initial state we put the arrow mark, and the final state we put the circle. And for the state q0, when it has the input symbol 0, it moves to the q0. It has 0 here and here. So when the input symbol is 0, it moves to itself, self loop, and when it has the input symbol 0, it also moves to the final state q1. So we write both q0 and q1. When the input symbol is 1, it moves to q0. That is it, a self loop. And for the final state, when it has the input symbol 0, it moves to the q1, and for same input symbol 1, it moves to the q1. That is, it ends with both any number of zeros or 1. Thank you everyone. Please share, subscribe.